Okay, we're continuing with transformations on the exponential function. And if you understood the earlier sections that we did on this, we're really not doing anything new. We're going to talk about stretches and compressions, vertical stretches and compressions, and we're actually going to skip horizontal ones. So that's good because those are a little more tricky. So we're going to do stretches. So we're going to put a value out front of there, a. And this is actually the basic function we talked about all the way at the beginning. The basic function of this starts with a stretch out here. So if you remember our previous section, if we have a function and we throw some kind of multiplier out front, it does exactly what we would think. It's going to stretch it vertically or compress it depending on the number. So if it was 3b to the x, we've now stretched it. If it was 1/3 b to the x, we've now compressed it. Now let's take a look here with some examples. So we have now thrown a 4 in front of the basic function. This is a vertical stretch of 4. And if we look at our original points, remember our two key points is you put in 0, you always get 1. You put in 1, you always get b. So b is the 1/2. Well, all we're going to do now is multiply the y's by 4. That's all we're doing. We're taking what we had before, we're vertically stretching it, which is y, vertical. So we're going to multiply by 4. Now 1/2 times 4 is 2. So we originally had 0, 1. Well, now we have 0, 4. We originally had 1 and 1/2. Now we have 1 and 2. And again, they've thrown in a third point, but I don't really need that. And because it's 1/2, you could have done it just from the dots. But because it's 1/2, you see we're decaying, so we're going down. Now, what about the domain, range, and the asymptote? Well, the domain hasn't changed. We still are hitting everywhere. The range hasn't changed. We didn't go up or down, so we still start hitting things just past 0 and go on forever. And we didn't do anything to affect the asymptote that runs across the x-axis at y = 0. So let's look again. Now I'm going to start. So we have a fraction in the front. It does what you think it would do. This is a vertical compression of 1/2. So let's look at our key points. You put in 0, you always get 1. You put in 1, you always get b, which is now 4. Okay, well, we're vertically compressing. We're multiplying the answer that you get on the output of the function by 1/2. So now I've got this. 1 times 1/2 is 1/2. 1 times 4 gets me 2. Okay, now this is growth because we have a b that's 4. So that's 1. I'm going to be 1/2 right here. This is 1, 2, 3, 4. We're right here. Oh, I'm sorry. No, we're doing this one. We're at 0, 1/2. We're now at 1 and 2. Now you could add another point, but that's good enough for me. And it would look like this. So we have compressed the function 4 to the x by a factor of 1/2. Now, domain, nothing's going to change there. We haven't done anything but compress, so it's not going to change any of the fundamentals. Our range is still going to be the same thing as it always is. Our horizontal asymptote is still at y is 0. If we had vertically, if we had lifted it vertically or lowered it vertically, that would be different, but we didn't. So all of those key points, the domain, range, and asymptote stay the same. Okay, now reflections are going to work the same. Remember, sometimes we'd flip it over the x-axis, sometimes we'd reflect it over the y-axis. Well, we're going to do the same here, and it follows the same idea. They want us to reflect this function about the x-axis. I like to just call it, we're going to turn it upside down. But the fancy term is we're going to reflect it about the x-axis. So that happened when you put a negative in front of the function. You put it all the way out front. Do you remember? That's going to take what you put in an x, you get a y, but now it's going to make that y a negative value. It's going to flip it upside down. So let's take a look at our key points. We have 0. Every time you put in 0, you get 1. You put in 1, you get b. Okay, now we've put a negative out front of all of this, so all the y's are now going to be negatives. That's all it's going to do. And by doing that, it's going to turn it upside down. So we've now graphed it. Now we do have some changes here. We have flipped it upside down. Now that hasn't changed the y asymptote. We're still not ever going to cross y = 0. Now how about the domain? Hasn't changed the domain either. We're still going to hit something everywhere if we had our ruler going up the x-axis. But what about the range? Well, it's upside down now. So if we're doing our ruler going up the y-axis, I'm immediately hitting at negative infinity, and you'd get all the way up to 0, and then you would stop. You would not want to include it. So just because we turn it upside down, we've essentially turned the range upside down as well. Okay, now this one, they want us to reflect it about the y-axis. So what we're going to do here is we're going to flip it over the y. Now, do you remember how we would do that before? If we want to flip over the y, we put a negative inside on the x. Do you remember this? So if you want to flip it down, you just put a negative out front. If you want to flip it across the y-axis, you're going to put a negative right there in front of the x. Okay, so let's look at our key points again. You always put in 0, you get out 1. You put in 1, you always get out b. Okay, well, if we have flipped this over the y-axis, isn't that going to change? It's going to flip the sign. Excuse me. It's going to flip the sign on all of the x values. It is. So it's going to flip the sign on both of these points. Just for the x, right? Because we're flipping over the y-axis. So the positive x's are now negative x's and vice versa. So if I had negative 0, well, that doesn't change anything. This point is actually not going to change at all. But if what I was at 1 is now at negative 1, 1.25. Now for this illustration, well, I'm going to add one more, but hold on. Okay, so I'm going to add one more point here. I'm going to say 2. Oh, no. I want to pick a negative point. Hold on. Okay, so if I had picked negative 1 originally, I would get 0.8. So just putting a negative 1 in there. Now I did this so that we could see this one would also change signs, and now he would become a positive 1 and a 0.8. So by flipping it over the y-axis, all we're doing is we're flipping the signs on all the values of x. Okay, now we're going to graph this. And interestingly, 0, 1 doesn't flip because it'd be like we're flipping the paper over this axis, but that was on the axis, so that would be fine. Now we have what was at 1, 1.25 is now at negative 1, 1.25. Now, our third point, I added 1 so it would make sense. We're now at 1 and 0.8. So we're like this. Okay, so we've just reflected it about the y by putting the negative in there upon the x. Okay, now we have multiple transformations here. Now I'll talk you through that. They've mercifully left off the horizontal stretches and compressions, but do you remember how this would work? Well, we're not deciphering them here. I'll talk about this in a minute. So we want to create a new function, and we're going to do some different things to it. So the first thing we're going to do is stretch it vertically. Well, we just put a 2 out in the front of this function, e to the x. Now we want to reflect it across the y-axis. Okay, so that's a right to left flip. Okay, so that's in on the x, remember? And then we want to go up 4 units, so we're going to add 4. So here's our new function. I have vertically stretched it by putting a 2 out front. I've flipped it over the y, and I've shifted it up 4. Now let me see if they have a picture of it. No, they don't. Okay, so let's talk about what happens to the asymptote, the domain, and the range. Well, the domain, nothing happens. So if we had our ruler out, we'd still be hitting everywhere. Now I'm not going to draw this one, but do you see what would happen here? We have moved that original function up. That's all we've done. So because we've moved it up, our range was 0 to infinity. It's now going to be 4 to infinity because we've moved it up. And our asymptote was at y equals 0. It's been moved up, and now it's at y is 4. Okay. Yeah, I was going to talk about the order that you have to graph them I don't, in these examples, it isn't necessary, but I guess I should just mention it again in case you see any other problems. So do you remember you're going to do right and left first? Anything that moves you right or left. If you have to graph, you go in this order. You do horizontal or vertical stretches or compressions. So far we haven't done any horizontal, so we're only doing vertical stretches or compressions. Man, that's written so badly. I don't even know why I'm writing it. That's so bad. Okay, right or left, vertical stretches, compressions. We do our flips. So our negative signs, either they're over x or over y, and then we do any shifts that move us up or down. Okay, so that is not being done here. They didn't give us one and say, hey, graph it, but I suspect if they're talking about all this, we might see problems like that in the text. Now let's just finish this. We got a vertical compression. Well, that does what you think. You just put the 1/3 in front. Okay, now what are we doing? Reflecting across the x-axis, so that's flipping down. When you go down, you put the negative out front, and then we're going to move the whole thing down 2 steps, like that. Now let's give it a name. So g sub x. All right, so they want the asymptote. Now we've moved it down. So the asymptote was at y equals 0. Now it's at y is -2. The domain, nothing's going to happen to the domain. But the range, because we moved down, we were at 0 to infinity. Now we're going to be at -2 to infinity. Okay, as usual here, not a ton of examples. I'm not quite sure what the problems look like in this section. If there's anything that I didn't cover here, I'll try to make some supplemental videos with some working through some problems.